Now let us see the concept of this root. Square root of a real number. Square root of real numbers. It's not no, okay? In one child was asking, madam, you have written no. It's number, okay, real number. So if a is a natural number, you know that natural number starts from 1. So a is a natural number. Then root a is equals to b. Okay, if b square is a. It looks very difficult, but it's very simple. I'll explain by taking example. You know that the square of 5 is 25. The square of 3 is 9. The square of 2 is 4. So if we write the square of 5 is 25, we can also write the square root of 25 is 5. This is the meaning of this line. Square root of 25 is 5. It means square of 5 is 25. They are reverse of each other, inverse of each other. Okay. Similarly, 3 square is 9. It means square root of 9 is 3. 2 square is 4. It means square root of 4 is 2. Okay. So in general, see, this is a square root. We can also, the same is for cubic root. Cubic root means cube of 3 is 8. So cubic root, we represent cubic root like this. We'll write 3 here. So cube of 2 is 8. It means cubic root of 8 is 2. Understood? Similarly, for nth, we can also find the nth root. Okay? Means 2 raised to the power n. Like this. Okay? Or any number raised to the power n. So nth root, how we'll write? This is root, cubic root. So nth root of any number. So nth root of any number. Nth root. Root, cubic root, 4 times, 5 times. Okay? So in general, nth root. So nth root of any number, any natural number is b. It means b raised to the power n is a. If you don't understand this concept right now, it's completely fine. You just see this example. From the example, you will be able to understand. Okay, this line looks very difficult, very tough, but actually it is not. You just see this example. Actually, these all are called radical signs. Radical sign. Okay. Now we will see some properties, some identities, and on the basis of these identities, we will solve questions from the exercise and from the examples. Let a and b be positive real numbers. We are only talking about real numbers which are positive, okay? Because within root, if any number is negative, like a root -2, then this is not real number. This is imaginary. This we will discuss in higher classes. So within the you only one thing you have to keep it in your mind: the number within the square root should be positive number. So here a and b be positive real numbers. Then the first identity is root within root ab is root a dot root b. You can this identity means the use of this identity is like, means if a number is written like 3 multiplied by 5, okay, then this can also be written as root 3 multiplied by root 5. Okay, the next is root ab, then root a by root b. Simple. If the number is root 3 by 5, then this can also be written as root 3 by root 5. Okay, separate we can write. separate we can put this root. And this 4 identities, see, root a plus root b multiplied by root a minus root b. This is same as a plus b, a minus b, which is equals to a square minus b square. But be careful, here we are getting a minus b. Why? Because if you use that identity a plus b, a minus b, which is equals to a square means root a square, minus b square means root b square, and root and then square of root is that number only, square of root is that number only. That is why we are getting a minus b. Okay. The next, a plus root b, a minus root b. Here again we will use the same identity, a plus b, a minus b. So a square, be careful, here there is no root over here. We have simply a. So we'll definitely get a square. And here root b square we will get, and root b square is b only. The next is root a plus root b multiplied by root c plus root d. So first here you had done in class 8. First we'll multiply this root a and this bracket plus root b and this bracket. So this will be the result. Okay, we will take example from based on each identity. Don't worry, because from this identities it's very difficult to understand, but from the example you will understand it better. Now similarly, root a plus root b the whole square. Now that identity a plus b the whole square we will use here, which is a square plus 2ab plus b square. Here a is root a, so root a square is a, root b square is b, and 2 root a b. Okay, now we will see question based on these identities.